I use these mirrors to focus solar radiation here, where the radiation creates high temperatures which produce steam. My mirrors adjust this reflective film, which costs 25 cents a square meter, and I'm looking for cheap replacements for the mirrors of these solar power plants which produce electricity at night as well as during daylight hours thanks to such heat storages. Unfortunately, these solar power plants are expensive, but cheap mirrors will make their electricity cheaper than electricity from thermal and nuclear power plants, and therefore my YouTube channel systematically describes my experiments with 10 types of cheap mirrors. My 5 previous videos describe cheap mirrors based on glass rectangles, mirror steel, reflective film on expanded polystyrene, mirror balloons, and reflective film on a concrete sheet. This video will be about the 6th type, which is the cheapest among those 10 types because it consists of that cheap reflective film on a similar structure of steel rods or wires. This structure was used for this mirror, which has a spherical shape and will be described in the second half of this video, but first of all I will describe my experiments with these two variants of mirrors with a cylindrical shape. The shape of my mirrors was determined by these wires, although thicker steel rods would provide more precise focusing, and now you see here how those wires provided the focusing of radiation from the sun. Also, this weight is very important for the shape of the mirror, and it stretches the film and reduces its wrinkles. I have measured the lifespan of my mirrors several times, and it turned out that they lived a little less than 1 year if their weak points are reinforced with such adhesive tape. I used very thin films, about 20 microns of mylar, but increasing their thickness may not make economic sense, because replacing the films is a very simple and quick action, and now I am showing how I removed and installed my films. This is the second variant of the mirrors, and it has this additional durable polymer film, which helps withstand strong winds. It turned out that the additional film increased the lifespan of the reflective film by almost 1.5 times, and we only have to replace the reflective film, because this additional film can be used for many more years. These two variants of primitive mirrors are interesting to direct additional solar radiation inside greenhouses, or onto the surfaces of solar panels, or onto solar collectors, or onto some primitive solar heaters. For example, I experimented with this solar heater, which receives solar radiation both directly from the sun and from the mirrors. This solar heater produces very cheap thermal energy, many times cheaper than heat from natural gas, but the temperature is not high, and for example, now you see that the mirror has heated that water to 93 degrees Celsius. At the same time, the production of cheap electricity requires temperatures of several hundred degrees, and this goal is achievable for the following mirrors. I repeat that this mirror consists only of these steel rods and this primitive reflective film. After installing the film on the rods, we have a concave mirror which focuses solar radiation here, and it is obvious that this spot must be inside such a receiver, where it must hit this black surface. Now we will look at its heating temperature, and here we see that the solar radiation hits the black surface to more than 300 degrees Celsius, which is enough to generate electricity. Now this newspaper will help us to make sure that the heating temperature is high, and we see that the solar radiation from my mirror ignites the newspaper. These experiments were shown in this my old video 4 months ago, which also showed the design of my receiver and ideas for more efficient alternatives to that receiver. It also explained other features of heat and electricity production, and I remind you that similar mirror dishes should form long rows, and the dishes focus solar radiation into similar receivers which have the ability to move in this direction, while the mirrors are motionless. These pipes are the paths for circulation of heat transfer fluid, which is heated by the solar radiation inside these receivers to 300 degrees Celsius and transfers this thermal energy to thousands of tons of concrete, sand, or other cheap materials, so that this heat produces electricity not only during sunny hours, but also at night and on cloudy days. Another my video showed the life of this mirror during 18 months when a strong wind finally tore its film, because the solar radiation gradually ate away the strength of the film during those 1.5 years, and this lifespan is recorded here. This formula leads us to this cheap solar thermal energy, half a cent per kilowatt hour, which is almost 10 times cheaper than the cost of heat from natural gas. Also, here you can see my target cost for the film replacements, and some ideas for the cheap replacements were described in another my old video, which also described how to solve the problem of these wrinkles and other problems of similar mirrors.